now we're going to open it up to questions, and we'll try to, we'll certainly leave, we'll have as much time as we can for questions. We're running a little bit behind schedule, but that's okay. So I'll sit up here, and I will, if you raise your hand, I'll try to direct the question to the right person. So if you could just stand and state your name and your affiliation, that'd be great. Okay, go ahead. We are, so the question was about the scope of the business. The company is based in Bellevue, so we are certainly a local company. We have about 24 engineers right now. We don't anticipate hiring hundreds of people. With a few dozen engineers, there's a great quote, which is, not only can small groups of people change the world, in fact, it's the only thing that ever has. And I firmly believe that.
If I could add, I mean, one of the reasons that we chose to announce the company at this time is because we're beginning to aggressively search for the world's best engineers to complement our team. And it's tough to do that in quiet.
Quiet mode. Okay, next question. Yes?
Sandy Dalton from the Seattle Times. Can you explain a little bit more what you intend to do in 2 years' time?
We'll repeat the question.
I'll repeat the question. So the question is, can you explain a little bit more about what you intend to do in 2 years' time? And I'll turn it over to Chris, but basically we're going to be launching our first Arcid 100 spacecraft. Chris, maybe you can talk for 30 seconds about that.
Yeah, so our plan that we're implementing right now is our Arcid Series 100 of spacecraft that is the core capability that we're going to build on to explore the asteroids. And there's a lot of cool things about this. We talked about some of its swarm expedition capabilities and using multiple things. Our spacecraft doesn't work alone, it works in teams. Its location in space, as Tom mentioned, gives it a unique vantage point into areas that we can't see from the telescopes on the ground. It's got a kind of a multi-tool or a Swiss Army knife style of capability.
Show the 102. Do you want to get up and
well,
show? Come on over. We'll let's have an interactive session here. So we have here a model, and I'll let Chris talk about it. Sure.
Yeah, so this is the 102. It's kind of got a Swiss Army knife in terms of its capabilities and what we're planning to do. And from a Swiss Army knife standpoint, a lot of what you do in space with remote sensing is limited by the size of your camera. Everyone here in the audience has big lenses, of course, and we need a big lens in space. And our entire spacecraft is designed around pointing that big space at the lens of the things we want to look at. And because we've invested so much in that big lens, we want to use it for more than one thing. I don't just want a knife on my Swiss Army knife. I want something that I can communicate with, something that I can point with, and something that I can take amazing asteroid data with. Another thing you can see, the boom coming out. This is something for some engagements we're planning with educational institutions. One of the things as engineers in putting our spacecraft on Mars that we always appreciated, and we find that everyone who rides along with NASA and its missions into the solar system, everyone loves seeing the spacecraft in the environment that it's exploring. So the pictures that we took on Spirit and Opportunity, the view down and seeing those dusty solar arrays, it kind of personalizes it for you. And we actually think that's important enough in our exploration to want, to know what's taking the pictures and what it sees, just not what its view is. And the other kind of just last part of it is just yeah, well, I'm trying to remember the last point. Yes, laser comms and swarm exploration. We're using some commercial technology and kind of taking things off of recent product lines and testing their capability for space and doing it in a way that we can kind of tolerate failure and graceful degradation. We have a capability on this to take payloads along with us. You may have heard of CubeSats, small spacecraft that can be deployed for educational or other scientific reasons. And it's also a test bed for our next generation of technology. So we don't want to just be doing the thing that we're doing today. We want to take that next opportunity for learning and be able to use our spacecraft that's up in space as the next opportunity to test. And it all starts with the 100 series. As we said, we'll be putting this in space starting the end of next year. And maybe one of the other things talking about mindset that is, we think, totally different and enabling to being able to explore dozens of asteroid targets is we can't just build one precious jewel that we treat with kid gloves and that we work on very carefully and no one touches it and we worry about the slightest scratch or breaking it. We need to make something in an assembly line, and we need to think about it making it an assembly line. And yeah, and it's not just the assembly line, you can crank out a lot of them. The whole way of thinking about how you approach the problem and how you solve problems just completely changes with that simple change in assumption.
Great. Okay, a couple more questions. Let's keep going here. Gentleman right here in the sweater. Do we have a mic, please?
Hi, Aubrey Cohen, Seattle PI. Can you set out some of your expected, or at least give a range of a timeline beyond this initial launch for when you expect to actually start sending these swarms of craft out to an asteroid, and then maybe to start mining and then even start delivering? And will that first delivery, do you expect, would that be to something that's exploring space, and then when would you bring things back to Earth?
So Peter's going to answer this question, but I should warn you that we do come from the Burt Rutan school of trying to avoid giving out timelines. But I'm sure he'll give a little bit of hints.
That's a great setup for me not to give out a timeline. But realistically, one of the things that's important is to keep costs of systems down, is to have small teams and move rapidly. Most of space projects end up taking on huge teams of people and taking long periods of time, and ultimately you eat up all the capital you have in simply labor hours. Having said that, the Arctic Series 100, which is in low Earth orbit without propulsion, is really our focus for the next 2 to 3 years. It's really imaging asteroids that are near Earth approaching. The Series 200 will add propulsion to it, and that will be the focus of the next couple years after that. And that propulsion is enough delta V, in other words, enough energy to move the system towards an asteroid that we see coming or near the Earth-Moon system. Ultimately, our goal is to hopefully identify the first asteroids to prospect within the decade. I won't say much more than that, other than our plan is to fly rapid iterations as frequently as possible to learn, iterate, and really more of a Silicon Valley way of building spacecraft.
Prospect before that, but choose the one. Okay, yeah. Sorry, just to be clear about the word prospecting, we'll be prospecting within just after we start launching the Series 100. But the prospecting may take years. There's just such a small population of the asteroids that have been discovered. We're gonna go after and learn, get the data and understand the resources and the positions and everything else. I think what the term we should use within the decade is really to have identified those which we will then begin extraction from.
Let me use the real estate analogy. If you think about it, there are, as we heard, millions of asteroids. Some percentage, if you would, thousands or so are come through the Earth-Moon system, are in some proximity. Of those, a percentage of those have the right energy distance, the right frequency of return to the Earth, the right makeup, and we hope we'll identify the top 10, 20, 30 of those asteroids that we want to go and send the Arctic Series 300 probes out to. So it's a real estate of, location, which are the most valuable ones for us to go and put our Series 300 probes on.
Next question. Yes, in the white jacket here.
Hi, I'm Deborah Wong from KUOW Public Radio. What do you have to find on these asteroids in order to make money? You're talking about tens of billions of dollars added to the GDP annually. Is that if you find platinum, a platinum asteroid, or does nickel and iron and water get you that return?
So, by the way, so the trillions of dollars added to GDP is absolutely true. We'll stand by that number, but it's over the next few decades. Okay, as the market for space resources grows, and it will grow every year, as we get out there, that will cumulatively add to our world GDP. And there was one chart we didn't have time to show, but we can send it to you later. But the valuable materials are the materials we go after first. And there's a great discussion and progression to show that water is in fact the gateway material because it enables everything else. When you enable water sourced in deep space, fuel is essentially free beyond that point. You can move around in the broader solar system using the fuel and propellants derived from water. So we clearly would go after the highest valuable materials first. Next question. Here in the glasses. Just one sec. Yeah.
Oh, thank you. Could you say a little bit about why you're located in Bellevue, and has to do with aerospace or software,
sure,
whatever,
yes.
and also
Would you like
in
to-
terms of
yeah.
this manufacturing, where will you be doing that?
Yeah,
so-
I can address that decision. As we founded our team and decided where in the world we wanted to operate, we considered a number of locations. I was personally in Los Angeles at the time, but we looked at Silicon Valley, we looked at other areas in the Southwest, but decided on Seattle because some of our investors were here and some of our partners were here, and we've really found it's just a beautiful place to live, and all of the infrastructure and the industry that's in the area is what we need to be able to do this. And as Doug said, we're starting the Silicon Valley of space up here in Seattle.
Here.
And
Next question. Gentleman back here, yes.
Hi, Mark Harris with The Economist. I'm wondering whether you've got any plans to commercialize the data from the Arkid 100 series, or perhaps are you going to share that data with both Planetary Defense or other ventures?
Yeah, it's a great question. And as we, there's certainly, depending on the mission, we're going to have partners. as we mentioned, developing our core technology roadmap, we will find, and in fact have already found, a number of customers along the way and partners with whom we work on specific missions or areas of technology. And I can absolutely imagine a scenario in which, for example, educational and university and other sorts of institutions would have a great interest in high performance, low cost observation platforms in space with whom the data derived from those platforms would be widely available. Don't you think, Doug, that places like museums and others might be interested in this sort
I
of
can tell you
capability?
that ever since we've heard of this project, the education people here at the museum have been salivating about the opportunity to use a public space telescope
Excellent.
and use it in our educational programs. We will definitely pursue that with you.
So let's keep going with questions here. Yes, in front.
Nat Seymour, B Technical Graphics. I wanted to know if the role of astronauts maybe in the long term is in your plan, or if you're going to be entirely robotic.
Peter, would you like to take that?
I think for this company, the focus is robotic. I mean, ultimately, we will form private-public partnerships with NASA, the same way that NASA has partnered with launch vehicles like SpaceX or Google Lunar X Prize teams. We'll partner with space agencies, but that's going to be really their focus right now. I think Eric and I have worked on suborbital and orbital flight to orbit, but asteroids right now are, I think, in our mindset for this company is a robotic endeavor.
When we add humans to the equation, it increases costs, and there may be missions in the future and mining expeditions
Sorry, Tom.
that require humans, but we would really try not to if we can, because it's better business. Okay, next question here.
Jason Potter with Wired. Can you run through a little bit of the math that would explain a mature system? For instance, how much would it cost to get the spacecraft onto an asteroid? What type of payload would have to be returned? And the value of the resources on board. How does that math work out?
Well, I won't go into the detailed math. We can, maybe later on we can do some of that. But just in terms of time, think of it like this: the size of this room, this gallery here, is probably what, 80 meters or something like that. Maybe close to that. So an asteroid that would fit in this room would certainly have $100 billion plus of materials, whether it was a water-rich asteroid or a platinum-rich asteroid. Probably a lot more than that, actually, if we did the numbers.
The water to power the whole shuttle program was in a 50 meter?
50 meter, yeah. So the point being that we can grok this size, okay? This is smaller in width than the space station. Space station's about 100 meters long, and granted it's a tube, but You don't have to run through a bunch of detailed calculations to realize that a small-ish asteroid has an extraordinary value if you find the right kind. And when we compare that to mining projects on the Earth that take, by the way, decades, platinum mines, deep sea oil platforms, all these different resource plays take decades to fully extract and to go through the full life cycle of those. It's clear that that's something that can be done, and it's not like you really need to map it out in a mathematical form to understand that that's possible.
A fact that impressed me that Chris and his engineering team pointed out, an asteroid about 50 meters in diameter, so let's call it half of this room size, of a carbonaceous chondrite type that has 20% ice typically, would have enough hydrogen and oxygen on that rock to power every one of the space shuttle flights in the history of the space shuttle program. It's an extraordinary amount.
Millions and millions of pounds of propellant on a rock, an icy rock the size of half this room. Okay, next question. Yes, lady here.
Hi, Venice Buhayan with Bellevue Patch. I was wondering, where are you going to be building your equipment, and from where are you going to be launching them?
I can address that.
Go ahead.
So we're building our equipment right here in Bellevue, in the Seattle area. And that's an important part of the strategy, is to be able to use our facilities and our people to do a lot of that. We are launching it on a variety of opportunities, and we see that as one of the key advantages of our approach. We don't actually need an entire rocket to get our spacecraft into space. We hitch a ride using things called rideshare, or secondary payloads, and we are making our configuration in our Orchid Series 100, and even the 200 and 300 after it, compatible with these rideshare opportunities to achieve the lowest cost in access to space that we can.
Okay, should we take a couple of questions from online? Where do we? Yes. We have a number. We have a few thousand people